Alright, the class you've all been waiting for, Chapter 5, Network Address Translation. And by that, I have no idea what I'm talking about. Alright, so NAT obviously is something that we use pretty much everywhere, but we're hoping it goes away. So, I don't know how to take that. Alright, so we're going to talk about NAT operation. We're going to talk about configuring NAT, how to troubleshoot NAT, and the summary. Now, because there's 3 different flavors of NAT, when we get to this configuring part, sometimes it gets kind of weird because in one version it takes 3 commands, in one version it takes 5 commands. So this would be a good time to start on your notes if you don't have any. And by that I mean you should have a piece of paper that says, hey, NAT, and then if I'm doing static NAT, these are the commands, and if I'm doing dynamic NAT, these are the commands, and if I'm doing port address translation, these are the commands. And then have it, because what's going to happen is, when you graduate, you're not going to get a job and they're going to say, oh, all right, you're in charge of all our routers. That's not going to happen. You're going to be, underneath somebody. You're going to be an entry-level network engineer or help desk guy. And there's going to be people above you that know all these things. And then depending on your initiative and what they think of you, they're going to move you up. And hey, okay, now. But eventually, in a couple years' time, they're going to say, all right, you can do this. And then it's going to be up to you. And then the last thing you want to do is go to a site, oh, let me go to the internet or something. It's a lot easier to pull out notes, and so people think that, oh, he's done this before, he knows what he's doing, he's got notes on this, as opposed to, oh, he's going to the internet because he has no clue what he's doing. So take that with a grain of salt. All right, so that's the stuff we're going to do. Hooray! All right, so first thing is NAT. Obviously, NAT came about because IP4 is lacking addresses. When IP4 first came out, the internet was very small. A couple of colleges and military installations, and that was it. And then once that started growing, they were like, hey, crap, this isn't going to work. We don't have enough addresses. We've only got, I want to say 16 million addresses or something. It wasn't going to be enough. So they're like, all right, we need to do something. So then they came up with this, request for conference 1918, and that was where NAT was proposed. So what they did was they said, hey, we're going to take one address range out of each class, and that's going to be a private range, and we'll let everybody use those internally. Because until that point, if you wanted to be on the internet, you had to have a public IP address. So if you were a college and you wanted, 4 workstations to be able to go out, you had to buy 4 IP addresses. So they took these, they made public and private IP addresses, and private IP addresses cannot be routed on the internet. All right, so that was NAT. So here's the address range. So it's just 10, 172.16 through 172.31, and then 192.168. Now 10 and 192 are kind of easy to remember because they're an entire range. But the B range is kind of different because it's several ranges. 172.16, 172.17, 172.18, all the way to 172.31. So occasionally you'll go to work for a place and they'll use 172.20. And you're like, crap, that's the public IP address. No, it's not. So make sure you're aware of that because that may rear its ugly head on our exam. Hooray! If you can't tell, I'm on spring break, so I'm kind of weird today. All right, so if several of you have forgotten in your intro networking class when we discussed NAT, and it was probably brought up again in your routing essentials class, NAT is the process that translates the public IP address into the private IP address. Most organizations use a private IP address internally. And then when that traffic goes out, it hits the router translates that into a public IP address, then the world sees us as a public IP address. So let me kind of give you an example of what that looks like. All right, so here's my wonderful drawing. So here's your PC over here on the left. Let me grab this, that way my pointer's bigger. Here's your PC on the left, and he's 192.168.1.100. He goes to his router, which is 192.168.1.1, and then he has a public IP address that goes to his service provider on the internet. And then the other service provider goes to the web services company, let's say it's GoDaddy, that goes to the web server that you're trying to get to. Now, inside the web server company, they're using 192.168.1.2. So they have the exact same IP address as you, but we never see that stuff because it's hidden behind NAT. So with NAT, let's talk about port numbers for just a second. with port numbers, there's 0 through 1023, and these are the well-known port numbers. These are the ones that are already established, that are physically assigned by the Internet Association and cannot change. Port 80 is the Internet, things like that. And then once you get to 1,000, so 1,024 through 49,151, those are the registered ports. Those are the ports owned by the Internet Association, and you have to register them, and I believe you pay a rent for them or something like that. But if you want to make anything available online, you have to register a port like that. And I'm not talking about a website. A website's just simple port 80. It's one of the well-known ports. But if you want, like a World of Warcraft has registered ports. Any online game has registered ports. And if you go to the wiki, you can see, like here, this actually shows you all the port numbers. So if we go down here to the registered ports, and let's go up the higher numbers, all the lower numbers, like from 1,000 to like 10,000, actually to 20,000, are all registered by different services, SQL, MySQL, things like that. So if we go up here to some bigger numbers, Gamecoin, I have no idea. That's probably some weird Bitcoin thing. Worms multiplayer is there. Battlefield Vietnam. The weird semantic stuff. EVE Online is down. I thought they were in the 1200s, but maybe they're in the 20s. But you get the idea. So if you're going to register a video game or something that has multiplayer, there you go. There's EVE Online. It is the 20,000. Source Engine for multiplayer. Quake 2. So anything that you want to run online, you have to register this port. So you go to the Internet Association, hey, I'd like to register a port, and they see if they can find you one. And there's not a whole lot that seem to be open. So then after that, you have what they call the dynamic, private, or ephemeral ports. And that's 49,152 all the way to 65,535. Now what that is, those are for your temporary ports. That's what your PC uses. That's the pool that your PC uses anytime he's going to send something. So in this case down here, my PC wants to open up a web browser and go to this web server. So when he opens up this packet, we'll say this is his packet here, he picks a random port number between 49,000 and 65,000. So in this case, he picks 50, and that's going to be his source. That's going to be him. But he's going to a web server, so he's going to port 80. And then the IP address is here, and then he's going to the public IP address of that server. Now, when we get into the names, when we start talking about those, any inside name is you. So your inside local is going to be what's local to you, what you see yourself as. So 192.168.1.100. But there's also an inside global, and that's what the world sees you as. So in this case, the world, when your packet hits the router's going to strip off your IP and put on this 65.111. So the 65.111 is your global, your inside global. So I'm going to make a packet real quick. And we're going to say the 65.1.1.1, and that is inside global. So that's what your router is going to do. He's going to strip one piece off and put this on. So let me get rid of this port number thing. Should have made the window so big. Alright, there you go. So your packet comes up and says, hey, I want to go to there. So packet comes up, and then the router gets it. The router says, hey, all right, I'm going to strip this off, and I'm going to put this in its place. But then the router does something else. He creates a NAT table, and in his NAT table he says, hey, port 50,000 now belongs to IP address 192.168.1.100. And he keeps that in his NAT table. And then this packet goes out on the internet. So then the packet goes out, and it finally gets there. And then they translate it back. And now when they send it back, remember the source and destination get switched. So they send it back to 65.111, and now the new destination port is 50,000. And then 80 becomes the source port because it's coming from there. So when this router gets it, he's like, oh, hey, this is coming in destined for 50,000. So I need to go to my NAT table. Oh, 50,000 is 192.168.1.100. So then he pulls this part off, puts that part back on, and then he sends the packet to the PC. So that's how our regular NAT works. And we call this version port address translation because it uses port numbers to translate between the internal addresses and the external addresses, or public and private. So hopefully that makes sense to you. And that's kind of the way that part works. And that's the part of NAT that almost every company has. Like at Stark State, we're all using 10 inside the network. At people's houses, they're using 192.168. But you can have as many at PCs really as possible because there are so many private ports, these ephemeral ports. So I got a choice of like 15,000 different ports that I can randomly choose. So what's the chance of my PC and my brother's PC or something like that both using the same ephemeral port at the same time and going to port 80 or something like that? So chances are very slim because I don't know, they're astronomical. I've known of no cases where that has actually ever happened. And I would imagine that if it did, NAT would have some way of sending it back to your PC. But again, that's way beyond the scope of this course. All right, so let's get back into the weird naming thing. All right, so now we know what NAT is, and we know how it works. We take an internal address and we send it out to an external address. But the terminology, and here's where it gets confusing. Any inside address is you, and any outside address is the target IP that you're trying to hit. 9 times out of 10, your outside local address is the same as your outside global address. So your outside address is always the same. But your inside address, that's you. Inside local is what you see yourself as when you run an IP config, and inside global is what you see your address as if you're out on the internet. So if you go to, what'smyip.com, that would show you your inside global address. So this chart kind of helps you a little bit. So you're 192.168.10.10, and then after your router, you're 192.168.200.226. So this is you, and then this is apparently your LAN cloud, and then this is your external router, and then this would go out to your ISP. So this is what your ISP has assigned to your company. So that's what the world sees you as. So anything that you see inside, so inside local is what I see when I run an IP config. Inside global is what I would see if I go to a website and do what'smyip.com. But you can see the outside local and the outside global are both the same, 200.1, 200.1. They're the web server I go to. Now, chances are that's not the web server's actual IP address. That's the IP address that they've assigned from the ISP that then gets translated internally. So you can see like the web server never knows what the exact IP address of my PC is, and I never know what the exact IP address of the web server is, because that stuff all gets translated. So because we both have to go through translators, neither of us sees what's behind the translator. So that's kind of it's almost a weakness in NAT, because now we don't have end-to-end traceability. We can't find things, which is why or how hackers and other places are able to do and get away with so much stuff, because they run through so many different NAT services, and then the FBI has to go and pull records, and okay, now what was this address translated to, and that stuff changes anytime you reboot the routers. So it's very hard to trace stuff globally across the world or across the internet. So hopefully with IP6, NAT goes away, but it won't happen anytime soon, because with IP6 we don't necessarily need NAT anymore. But a lot of people are afraid to change. They'll just have a consultant come in and put IP6 on their border router, and then they'll convert it to IP4 inside. So we'll still be doing some weird versions of NAT and some stuff. So NAT's not going to go away. You're going to see NAT for at least the next 15 years out there in the world. All right, so there's 3 types of NAT that I discussed, and the first one is static NAT, and this is still very popular today, especially any company that has like an extra web server or something that hosts it externally. So with static NAT, it's a one-to-one mapping. So I map an IP address, a public IP address, to a specific private IP address. So let's say you've got your company and you've already bought one IP address from your ISP, and everybody uses that to get out to the internet, and you have what they call port address translation set up, which was the example we showed. So now you're using port numbers, and now you got 50 employees, and they can all go out to the internet and share the same IP address. Well, then you decide, hey, my company needs a web server, and we've got people inside that can do that, so I'm going to host a web server internally. Well, you can't use your same IP address for the web server inside. So what you do is you buy a second IP address from your ISP, and then you map that IP address directly to the internal IP address of the web server, and then you are all set. So then you have one IP address to hit your web server, and then one IP address for your people to use internally for their internet browser. So with static NAT, we are not using port numbers. We're actually mapping a public IP address to a private IP address. So when anybody hits that private IP, or the public IP address on the router from the outside, then static NAT physically points it to the one IP address internally, your private IP address. So static NAT's actually pretty easy to set up. So in this case, I don't know why you'd have 3 PCs and you'd buy 3 IP addresses, which is kind of weird, but that's just their example. So you bought 3 IP addresses and you statically map them. So in this case, there is no port number translation going on. It's just, hey, something's coming in for 227. Okay, I need to translate that to .11. Hey, something's coming in for 228. I need to translate that to .12. So we're not using the port number for the translation. It's a one-to-one mapping. There's an actual NAT table that says, hey, this address goes to this address. So that's static NAT. And again, we typically see that when a company has several internal one or more internal resources they want access from outside, a web server, an email server, a file server, something like that. Although in many cases we're not doing this because this is a little bit more complicated. You can just set up an SSL appliance and it does all that stuff for you. But I digress. We're talking about NAT. All right. Now, dynamic NAT is a little bit different. Dynamic NAT uses a pool of addresses. And depending on where you're at, you can get a lot of different stuff here, or a lot of different uses out of this. There's not a lot of people that I know that are using it. Any company with, like 200 employees or less is not using dynamic NAT to my knowledge. In the early days, when we set up the internet, we would use a dynamic NAT. So I would buy 10 IP addresses. And then what would happen is the first 10 people to try to use the internet would each claim one of those addresses. And then the 11th person was no longer able to go to the internet. He had to wait until one of the first 10 dropped their internet connection, which would put the address back in the pool. So there was a pool of addresses you could use, so it was kind of like musical chairs. Once all the chairs were taken, you couldn't get out. Now, we can... I don't even know where I was going to go with that. But you get the idea. So in this case, we got 5 addresses that we rent from our ISP, and then the first guy to get out, oh, hey, .12 went out, so he grabbed the first address, so now there's 4 addresses that are available. Now, specific, just using dynamic NAT, as far as I know, it's not really used a whole lot in the world today. But what we do see is we see dynamic NAT used in combination with port address translation, the first example I showed you, which is also the third kind. So there are 3 kinds of NAT. There's static NAT, dynamic NAT, and port address translation. But you can combine them, and then we'll talk about that when we get in the configuration mode. Now, why would you ever need to combine those 2? Well, look at a college like ours, let's say 15,000 students. Well, out of that 15,000 students, how many can access the internet at one time? Remember, there's only 15,000 temporary ports. Well, if I've got, I don't know, what do you say, 5,000 people all accessing the internet or something? So there's anytime you have a large population of people that could be going out to the internet, then you run the risk of 2 PCs generating the same ephemeral port, that temporary port. And you don't want that. So that's when you would have a pool of addresses. So when somebody generates the same port number as somebody else, the router would get it, and then the router NAT translation, oh, I already have port 50 in there for this IP address, so I'm going to put port 50 in there for this IP address. And it gives them a different IP address. So that's kind of like where dynamic NAT could actually be used, but you would have to combine it with port address translation. And I hope I confuse the crap out of you. Make sure if you bring that up in class, and I'm more than happy to explain that example for you. It makes a lot more sense when I'm there doing it on the board than trying to explain it here in a video when I've had a beer or 2. All right. And then there's port address translation. So those are the three times. There's SNAT, which is static NAT, one-to-one mapping. There's DNAT, or dynamic NAT, which is a pool of addresses that you use that you map directly to addresses. So the first two don't use port numbers. Excuse me. But the last one, port address translation, is port address translation. So it uses port numbers to map, and it can map one to many. And sometimes it's also referred to as overload, because now you're not taking, it's not one-to-one, it's, hey, I can put 50 addresses on this address. I can put 200 addresses using this address, things like that. So as long as you typically have under 1,000 addresses, excuse me. Anyway, sorry about that. So, totally lost what I was saying. But, you know, as long as you got 1,000 or less employees, port address translation will probably work, because what's the chance of all 1,000 getting out there going to the internet at the same time, and what's the chance of 2 of those generating the same port number randomly out of 15,000 something port numbers? So it's only bigger, huge companies that have to combine these resources together. So we've already discussed port address translation. So NAT typically is a one-to-one mapping. You know, even with the pools, when an address, a public or a private address comes to use one, we map it one-to-one. And then when we're out of addresses in the pool, then nobody can get out. So with typical NAT, it's just an IP address mapping, public to private. But with PAT, now we're talking about, hey, we want multiple people to be able to use this. And we do that by port numbers, which is that example that I showed you in Paint. All right. So what does NAT do? Obviously, it conserved IP addresses, so it saved the IP4's butt. And those people that came up with it that thought, oh, the internet will never grow over 100 users. Anyway, they say it increases the flexibility of connections. I don't know about that. Provides consistency for internal networks. Well, it makes all internal networks the same. If they're under 200 addresses, they're 192. If they're under a couple thousand, they're 172. And if they're more than several thousand, then they're 10. So it doesn't provide consistency. And they say it provides network security, and that's where we were talking about. Nobody knows what your internal network is, what IP address scheme you're using, because it blocks it through NAT. But that's also a disadvantage, because now we don't have any end-to-end traceability. So it's a lot harder to track the bad guys. So also the performance is degraded. Remember, when we talked about NAT, remember, my router has to do a translation, so I'm just going to send one packet from me to the email server, or I'm sorry, to the web server and back to bring up a web page. So my server or my router has to do a NAT translation. Then it goes across the internet and it hits their router. Their router does a translation and converts it to their internal address. Then he creates the web packet, sends it back, and then it gets translated again to go out to the internet. Then it hits my router, gets translated again. So there's 4 translations that have to happen just to send one packet back and forth round trip. So as humans, would we notice the difference? Probably not. But if we used benchmarking software, we could. And if we could eliminate that and several other things, then we would actually see a noticeable improvement that we could see with the human eye. So that's why we want to get rid of NAT. And also, obviously, tunneling is more complicated. So there's all kinds of issues with NAT. So in the real world, we want to get rid of NAT. But it's probably not going to happen for the next 15 to 20 years because IT guys are typically resistant to change. They don't want to learn new things. Hey, I've been doing it this way for 10 years since we had Windows NT. That kind of weird stuff. I mean, we still got guys using hubs out there. Anyway, I digress. All right, configuring NAT. If you're confused now, it's only going to get worse. All right, but hopefully I can make it so it's not so bad. All right, so with static NATing, there's really only 2 things you got to do. I got to create the mapping. I got to map and say, hey, map this IP address to this IP address. And then I got to say, hey, who's going to be the inside and who's going to be the outside? So with all configuration of NAT, you have to go to the 2 interfaces and say, hey, you're going to be the outside interface, you're going to be the inside interface. So now with static NAT, which is the easiest, there's just, other than that, you just do a mapping statement. So it looks like this. So the command is, and here it looks confusing when you first look at it, but it's okay. So IP NAT, that turns on NAT. And then I'm going to map an inside address to an outside source. So inside source. And that's going to be a static mapping. And then I'm going to take my inside 192.168.10.254 and I'm going to map it to 209.165 blah blah. So IPNAT inside outside, inside outside, and then the only difference is you add the word static in there. So that's the mapping command. Then you go to the two interfaces. Wow, I really need to go to bed, back to bed. And then you just turn on, one is hey, you're going to be the inside, you're going to be the outside. So IPNAT inside, IPNAT outside, and you're all done. So those are only 3 commands for static natting. We do this in the firewall class, and you do this here, so hopefully by the time you get out in the real world, you've got this in your notes and you're good. So a mapping, and then I turn on the inside and turn on the outside. So don't forget, anytime we do NAT, no matter what version, you're going to set the inside interface and the outside interface. So you have to set those. All right, analyzing that, we don't really have to do that because we've already talked about the inside local, inside global enough, and you guys are good with that stuff. You know how the addresses go. Now, the bread and butter NAT command, show IP NAT translations. Show IP NAT translations will show you any NAT statement set up on your router. So in this case, it's saying, hey, I got 192.168 blah, and it's reassigned to this. So my inside global, what the world sees me as, is translated to what I actually am. Now, in this case, I don't see anything. And the reason for that is, why these are blank is, I don't currently have a connection going outside. So as long as there's no connection outside, I'm not going to anywhere, so these will show up blank. Now, if I do have an active session, like I'm actually going out to the internet, these will show up. So that's your big bread and butter command. From there you can see, hey, did I set NAT up correctly? And if this is set up correctly, your only other option is to go look at the interfaces and make sure you didn't do them backwards and do the inside as the outside or outside as inside, you know, with the easy commands, IPNAT inside, IPNAT outside. Other than that, you're not going to screw it up. It's either you screw up the mapping command or you screw up the inside and outside. That's it. There's only those commands. So that's your big bread and butter command. Now, you can also show IPNAT statistics, and you can see, you know, how many active translations are going on and things like that. You can also clear the statistics, and that way if you want to run them every day and then check them at the end of the day to see how often they're being used or something like that. Some places that you may actually need to do that. All right, dynamic NAT. Here's where it gets weird, and this is why I'm glad we don't use this command a whole lot. So now there's 5 commands with dynamic NAT. Remember, you gotta have a pool of addresses, so you gotta create the pool, and then it uses an ACL to decide who's allowed to use those. So there's always an ACL that permits your internal address range, and then you gotta map the pool to the ACL. So instead of just one single mapping statement, I got to create the pool, then I got to create an ACL to say who's allowed to use the pool, and then I got to map those two together, and then I do the inside-outside. So when you think of it like that, it makes a lot of sense. So do they even show you it? No, they don't show you an example. But here I create the pool, so IPNAT pool, you know, pool, and then my start IP and my end IP, and then subnet mask if I want to put that in there. And then access list 5 permit 192.168, you know, 1.0 space 0.0.0.255. And then I put them all together. So IPNAT inside going to the source list, and so I'm going to list 1 because that was my access list 1, and then pool and whatever I name my pool, and then inside outside. So I create the pool, I create an access list that allows my internal users to use the pool, I map those two together, and then I set the inside and outside. So hopefully that's clear as mud to you now. All right, analyzing, we don't need that, blah, blah. All right, verifying again, show IPNAT translations is your bread and butter. Now you can also do show IPNAT verbose and get a little bit more information. Hey, when were they used? When was it created? That kind of stuff. But most of the time it's like, hey, my NAT's not working. I need to see why. Show IPNAT translations is always your first go-to command. All right, again, IPNAT statistics, clear the statistics. Remember, these ones show up as dynamic, although hopefully you won't see any of these. Now, here's where they get weird. Here's where they're talking about now I need a NAT pool, and I want to do that with PAT. So I want to do like dynamic PAT. I want PAT with an address pool. Now, this is only for typically your largest companies, where there is a chance that you have so many internet users that 2 of them could, theoretically, generate the same random number out of that ephemeral pool. So in that case, we need more IP addresses because I can't assign two IP addresses to the same port number. So I'd have to give it a different IP address. So in this case, it's the same 5 steps as with dynamic NAT. You got to create the pool first. So IP NAT pool, and I'm going to call it NAT pool. And then I'm going to add address range, 226 through 224, and then the net mask is going to be the subnet mask. And then I create the ACL, so access list 1, permit 192.168.0.0 space 0000. And then I put those two together, so IP NAT inside to the source, and it's going to be list 1 to pool NAT 2. And then I use the word overload because now we're adding PAT to that. So the only difference between these commands is the word overload, and that's when you're going from dynamic NAT to using PAT with an address pool. All right, and then you do your inside and your outside interface. So if the configuration was confusing when we talked about that, there are your commands written out for you. Now, for dynamic NAT, we just take off the word overload. And then when we're using dynamic NAT with PAT, then we add the word overload, and that's it. So hopefully that kind of makes it make sense to you. All right, and then the kind of NAT that you're typically going to see is with a single address. So with a single address, again, we create the access list. Access list 10, permit, 192.168, that kind of. It's the very easy access list to create. And then we assign the access list to the port. The interface number. The port, I'm such a dork sometimes. So IP NAT, inside outside, or inside source, and then list, access list 10, or whatever access list we used, and then interface, FA01, and then the word overload. And that says, hey, okay, we're gonna overload this port, and he's gonna do port number and build that NAT table on that interface. And then we do inside outside. So what does that look like? All right, so here's what it looks like if you actually do the command. So again, first you create the ACL. So in this case, I use 2 steps to create the ACL. So IP access list extended, and this is going to be port address translation traffic. And then I said, okay, 10 permit IP. Now you don't have to do this in 2 commands. You can just do this with access list 10 permit blah. So and then I did the mapping. So IP NAT turns on NAT. And then I want to do inside outside, so it's always inside source. I always remember it as inside outside. And then I'm going to use an access list, and the access list is named this. And I'm going to use it on interface, serial, whatever. And then I'm going to turn on overload. And then I go to my 2 interfaces, and I make one the outside and one the inside. And that's it. So hopefully that makes a lot more sense to you. All right, so analyzing, we don't need to know the inside outside. We already talked about these global and inside, blah. All right, again, show IP NAT translations is your big bread and butter command. And it'll actually show you, show IP NAT, the actual port numbers that are being used, which is kind of cool. So now port forwarding is a little bit different. With port forwarding, what we do is when traffic comes in to a specific port, we can forward. So as a company, you can also use this to go to your web server. So as an example, when anybody in your company is going out to the internet, they're going to use port 80. But there should be no internal traffic pointed to you on port 80. So you can have a web server and then just port forward, hey, anything that's coming into my router. Oops, sorry about that. Just got a phone call and totally lost track of where I was at. So what I was saying was your router's not used to getting port 80 traffic because there's no need for port 80 to be incoming to your router because you don't have any web sources. So you could host a web server and then say, hey, anything for port 80, go to this web server. So you could just do a mapping for port 80 goes to here. And that's what we do at home. Like when I create I created a Minecraft server for my son because he wanted to play with some of his friends. So basically, I set up the Minecraft server, and then I just went to my router and set the port number for Minecraft to go to this IP address. So that way, you could have a web server at your company, and you would not have to buy a second IP address. You could still use your original IP address. You could just port forward it. So that part where I said you can't do that was totally, I don't know what I was thinking. Again, it's early morning, I've had a beer, you understand. So that's port forwarding. Now, remember, SOHO stands for Small Office Home Office, and they used to sell specific SOHO appliances. Nowadays, they all have different names and stuff, and so occasionally you'll see the word SOHO, but it was popular for a little while. where everything was named Soho. But now we're talking about, hey, I got a big headquarters office, and I start building out these branch offices, which kind of seems to be the norm now. And I just want a small appliance that matches my big appliance. So I've got a big, what's called WatchGuard firewall. So I'll buy a small WatchGuard Soho, and I'll put that at my branch office, and then they'll talk to each other and create the tunnel across the internet, and then they can kind of do everything together. So I can do port forwarding, I can do encryption across the internet, whatever I want to do. All right, now you can also port forward through your router. So again, you can do this at your business if you didn't use a firewall. And trust me, there are some people that do not have a firewall, and what goes through their heads, I have no idea. But we had a client call us, and their IT guy had ordered a huge, I can't remember the model number of it, router, and that was going to be their perimeter router. And he wanted all the security set up on the router, not on a firewall. And it's like, dude, what? And this was also a company that only had like 50-something employees. So, and they probably spent like, I don't know, like $4,000 or $5,000 on this router. And it was like a manufacturing company, so there wasn't like a whole lot of people going to be on the internet. But anyway, you get the idea. And no branch offices. I don't know what the guy was thinking. So I digress. So, in this case, you just put the port numbers behind the static mapping. So, oh my God, freaking cat. Sorry. So IPNAT, inside, outside, static mapping, and then we're going to use TCP. Remember, you can use TCP or UDP. So I have to pick the protocol specifically, and then 192.168.10.whatever port 80, and then that's going to get mapped to my external address of port 8080. So then if any traffic comes in from the outside on port 8080, it would get translated to my web server on 192.168.10.254 port 80. And then you do the inside-outside. All right. So with IP6, do we need NAT? No. And I don't know why anybody would want to ever do NAT again. Now, the reason we don't have to do that with IP6 is there are 340 undecillion, I hope I'm not probably tearing that word up, addresses. So what does that look like? All right. So after million comes billion, and then we add 3 zeros and it's a trillion. Then we add 3 zeros and it's a quadrillion. Then we add 3 zeros and it's a quintillion. Then we add 3 zeros and it's a sextillion. Then we add 3 more zeros and it's a septillion. Then we add 3 more zeros and it's an octillion. Then we add 3 more zeros and it's a nonillion. Then we add 3 more zeros and it's a decillion. Then we add 3 more zeros and we finally come to undecillion. So it's 10 to the 36th power. Most calculators will choke and die when you do 10 to the 36th power. So that's how many possible addresses there are. There are only like 6 or 7 billion people on the planet. So now we're talking about if there's this many people on the planet and I have this many addresses, each person can have 1 million addresses and we would still have extra. So unless the world goes on a rampage baby streak for 50 years, we're probably good with addresses. All right. So again, so many addresses, there's no need for it. If when you get your prefix, your IP6 prefix from your ISP, that one prefix is able to do 65,000 networks, and each of those networks really has an unlimited number of hosts. So that's a lot of stuff. So each person, or actually each household, would really only need one IP6 address. You could use the 4th hextet, and 0000 is stuff for the house, and 0001 is dad stuff, and 0002 is mom stuff. So it's just amazing the amount of addresses that you have in IP6. Plus, it has security and stuff built into it. All right, so they did build a form of NAT into here. Why? I have no idea, and I sure hope we never use it in the real world. But they've reserved the addresses FC00 to FDFF as the unique local addresses. So don't get those confused with the link local addresses we've been talking about in our class, the FC or FE80. That's totally different. These are for NATing purposes only. So I don't even want to touch those. Let's just skip those. So again, there is that NATing. There, we can also NAT, like I said, some people are going to put IP6 on their perimeter router and still run IP4 internally, and that's called NET64 because we're using NAT to translate from IP6 to IP4, and that's a form of NAT. But again, that's not recommended. You can do, like Stark State now at the college. If you do an ipconfig/all, you'll see that we have IP6 and IP4 running. So that's what they recommend now. Let's run them both, and that way you can take traffic from both. And as soon as all the popular and all the good stuff quits using IP4, we can pull that off of our network. Which is kind of funny because here's what I see in the future. And I'm talking 50 years down the road. I'm seeing the ISPs still leaving IP4 kind of in their routing tables and stuff. And I see kind of an underground network forming that uses IP4 because the rest of the world is using IP6, so they'll have no idea how to use IP4 or how to get to IP4 or any of that stuff. So it's just a weird notion that kind of pops in my head every once in a while. Although I won't be around to see it, so maybe you guys will. All right, so blah. All right, so troubleshooting NAT. Remember, your bread and butter command is show IP NAT translations. Did I set the NAT up correctly? And then look at the information, look at the statistics, what's going on. So remember, you can always clear those statistics and then start watching them again, and that way you can kind of see things as they happen. All right, then there's the old standby. The debug IP NAT will show you all the NATing that goes on as it's happening, and that way you can see, hey, what address is it trying to translate into what? But again, with NAT, most of your issues are going to be, hey, did I make the mapping statement correctly? And if I did I turn the inside and the outside on correctly? So that's pretty much it. Remember, 3 types of NAT: static NAT or SNAT, dynamic NAT, DNAT, and then PAT or overload. So they all have a nickname. So static NAT is a one-to-one mapping, one IP address to one internal IP address. Dynamic NAT uses a pool of addresses that everybody can use, so the first 2 only map by IP addresses. And then PAT, or port address translation, uses a port number, and then its nickname is overload. So when you combine that, let's say when we combine port address translation with dynamic address translation, we have to add the word overload to the last command, or to the third command, before we assign those interfaces. And remember, your big bread and butter command is show IP NAT translations. And if your translation is correct, the next thing I always do is do a show run pipe include interfaces, and I check my interfaces to see which one has been assigned the inside, which one's been the outside, to make sure that's correct. And usually between those 2 commands, you find 99% of your issues. All right, so that kind of wraps it up. So again, if you have any questions, bring them up in class. If you wanted me to show you on the board how a big organization like a college that has thousands and thousands of students that could be out on the internet, how they use a dynamic NAT pool with port address translation, bring that up and I'll work that example on the board. Now, on your hands-on exam that's coming up at the end of the semester, don't forget you will have to configure NAT. They'll either ask you to do a static NAT or they'll ask you to do a port address translation NAT. They will not ask you to do a dynamic. So make sure that you're good with the static NAT and PAT. You can set those both up. Remember, static NAT has 3 commands. I map the IP addresses and then inside outside. And then with port address translation, I create an ACL. I create the mapping of the ACL to the overload command to the interface. And then I just set the inside outside. So make sure you have those commands down. All right, guys. See you in class.